the doors. I just want to give everyone fair warning. This is quite a depressing talk. It might drive you to drink. Preferably whiskey. In fact, I'm trying to find a sponsor in big alcohol at the moment. So fair warning, if you want something that's a bit lighter, fluffy, more optimistic, maybe not this talk. All right, well, you're all locked in. Too late. Great. Welcome to my talk. I'm talking about security theater. A bit about myself, first of all. I work for Booking.com, and that is currently my biggest project at the moment. Let me tell you, that is a resource-sucking project. And if anyone does want to follow me or send me questions or harass me, please don't harass me. You can get me on Twitter on that handle, and I'm very happy to answer questions. My DMs are open. Be nice. So, welcome to therapy. Please take your seats. It's good to see so many new faces here in the crowd. Now, we're all here because we think we have a very good relationship with security. You think you get on well. You swap jokes, you hang out, you make fun of other people who have security problems. But I'm here to tell you today that you've been conned. You all thought you were dating security when actually you were dating its way more attractive sibling, security theater. Security theater being the act of showing effort and energy towards creating the illusion of security without actually doing it. And I'm sorry to inform you of this, but this goes for pretty much all of us, myself included. But before we begin, this is very much a blame-free zone. We've all made mistakes. We're not going to be picking out on anyone. I'm going to show you examples of bad security. This is not to pick on those people or those organizations, so please don't take it as that. This is more to show the problems that we all experience. Now, I bet someone here, at least one person, hands up, I'm full of shit. Yeah, you do good security. How can this person stand up in front of you and tell you, you don't do good security? Great, we're on the first step. See, this is a breakup, and that comes with stages of grief. The first being denial. Let's begin. So, the illusion of security. Does anyone know what these are? Yes, these are the TSA skeleton keys. If you've ever been to the shops to buy a bag, as you do when you travel, you might have seen TSA verified suitcases. What that actually means, pretty much all it means, is it means the TSA has a master key that can open your bag, which means they don't have to break a lock on your bag if they decide to open your bag at any one point. Which is fine in theory. It's not fine. But what it does mean is if your bags go anywhere, the TSA can open it. And only the TSA could open it until this individual held up the TSA master keys for a journalist to take a photo of. Within 24 hours of this article being published, you could buy 3D printed copies of these keys on eBay. Now, here's the problem. TSA didn't tell anyone. TSA did not stop its verification process, and anyone who's bought a bag now has to add their own lock to the system, which kind of defeats the whole point of it. And no one's going to go buy a new bag just because they lost their keys and they want to make new ones maybe, because why? Those bags are expensive. Yeah, it's £200-300 for a bag. So this is an example of security theater that actually caused more security problems than it solved. Now you might say, fine, that's the TSA. It's only an organization that has the power of life over people trying to get in and out of a country. I'm way more responsible. I know OWASP. Does anyone not know what OWASP is? All right. OWASP is the Open Web Application Security Project, and I had to look that up, so don't feel bad. And their job, besides telling us how we should be securing our website, is to compile a yearly report on what are the most common vulnerabilities in websites. And that list has not changed in the last 10 years. Which means we haven't learned anything. If people are still being compromised the same ways, it means we know about it, we've known about it for the last 10 years, but we still haven't resolved the problems. In fact, we can't even call them advanced or sophisticated ways of being compromised, which a lot of Fortune 500 companies do. They say, oh, we were hacked by advanced hackers, and they had a SQL injection. Yeah, okay, maybe my applications aren't as secure as they could be, or maybe there are some vulnerabilities, but I know my personal computer's safe. I use antivirus. Fantastic. I'm going to introduce you to a technique called crypting. Now, crypting is a process where you take a piece of a virus or a malware, and you run it through an obfuscator. And then you run it against every single available antivirus on the market. Any of them says, oh, still a virus, you run it through the obfuscator again. And you keep doing that process until none of the available antiviruses on the market detect it, which pretty much bypasses every form of antivirus heuristics or fingerprinting that is currently available on all your computers right now. And they're organized. There are companies that provide online crypting services with built-in plugins for Jenkins, so you can go into your build process where you compile your code, push it to Git. It ships it off to the producers, runs it through their obfuscator, brings it back in nice packaged forms, and you can send it out to every single operating system you care about. They're organized. They take Bitcoin. They provide online internet support, which is better than a lot of online companies I've dealt with before. Let's see how the people who are meant to be protecting us do. Microtrend, that's a British company, isn't it? So they installed an unsecured Node.js server on your computer. If you're running Trend Micro right now, you have a Node server running on your computer. They did this so they could inject your passwords into the web browsers without having to do complicated add-ons and get around all the restrictions that browsers pass on stuff happening on your computer and stuff that's happening in the web browser. What they failed to do was to secure it, which allowed anyone's website you landed on to execute root commands on your computer. This is the software that has root access to your machine, that has allowed itself to be hooked into multiple parts of your operating system. That is meant to be protecting you. I mean, that's the end game, is they protect you from the baddies. Oh, and they could also steal all your master passwords because they weren't encrypted. And then there's Sophos. Sophos had a buffer overflow in the bit of software that actually scans whether something is a virus. So anytime it scans something to see if it's a virus, you could execute a buffer overflow and completely take control of the computer. And since a lot of these antiviruses hook into things like your mailing process, they even middle in the man, your websites, pretty much anything you're doing goes through this. I could send you an email, and Sophos would intercept it before it got to your mail client and scan it, and I could take over your computer by sending you an email that you don't even have to open. Well, that's just two. I'm sure some of the others are much better. I mean, there's all sorts of available options out there. Some of them are good. Not all of them are resource hogs. Until this one came along, the double agent attack. This came out in March. And it pretty much went like this. I want to take over your computer. I need to get the highest level access possible. I'm going to take over your antivirus. And this form of attack actually allowed viruses to take over and run as the antivirus, the thing that's meant to be stopping the viruses, and in a very privileged way. And no antivirus is ever going to tell you that it is a virus. You will find out if you install two antiviruses on the same machine, they'll tell you that the other one's is a virus and try and delete it. Which either is a really good marketing strategy or it's just being very honest. However, I was very thorough in this, and I wanted to make sure that I could check that if there's any antivirus available out there, so I've compiled a complete list of all antiviruses that have not had a major problem in the last year. It's a bit embarrassing, isn't it? I don't run antivirus anymore. It doesn't mean I'm sane. It also means I'm bad at security, but quite honestly, it's a bit of a, which is worse. And then there's this. And the S in IoT stands for security, if anyone has heard that. And I'll show you in one very simple example why this is terrible for security by showing you one device, one Internet of Things device. That, hands up if anyone has one of these. Who doesn't have a router? Right. When was the last time you updated the software in your router? Last week. Very good. Very good. Probably nothing's come out since then, but we're not sure yet. So a lot of these have software put on them that's at least 2 to 3 years old. Some of them 5, some of them 6, depends how long you've had them. Your internet service provider doesn't often update these. They don't send you a new one every few years. A lot of them still have the Heartbleed vulnerability because a lot of them bundle OpenSSL. These are things that everyone has. They've been around for a long time, and we still don't have a good way to update them automatically. Never mind the millions of other things that are going to be coming out in the near future where no one has a plan for how to update them. And this is Shodan. Shodan is the Google of Internet of Things. If you want to find an unsecured web camera in a country, you can type it in there. It'll show it. You want to find an unsecured German power plant? Yes, it is on there. There is actually some fantastic talks online. If you search for DEF CON and Shodan, that literally is an entire talk just on the interesting things they found connected to the internet with no security. And then there's this. So at the moment, there's a Dutch advocacy group who are trying to enforce Samsung to pledge to making sure that your phone that you buy gets security updates for 2 years. Just 2 years. Because that's kind of the lifespan of your average phone. 2 years, then you buy a new one. Just to get them to make sure your phone is secured for the 2 years that you have it for. A lot of people have them for longer, but the fact they have to go to court about this matter to ensure that the phone that pretty much is your entire life gets security updates. And they don't even have to make them themselves. Google makes them. Thing is, we're all pretty bad at security, one way or another. We might be good in some areas. We might be very good with the code we write, but we're very sloppy about some of the other things we do. Our users are really bad at security. Even us as users are bad. We use weak passwords. We reuse passwords. We use really stupid password reset questions. We fall for clickbait and spear phishing. At Booking, we spear phish our employees, especially the new ones. They've been with us 2 weeks. We send them spear phishing, see if they type in their password and username on a website that looks like Booking.com. So we'll buy Booking.com. Send them to that, say, oh, yeah, to access this, please put in your username and password. And unfortunately, we don't get a count of 0 people doing that yet. There's always someone who will give away their username and password without checking. We type in URLs incorrectly, which is how we get to those sites. We still open attachments. We find workarounds to how the system works because we want convenience over security. And that's the biggest problem. Convenience over security will always win. As developers, we're bad at security. This is a search I did on GitHub. You go through all the effort of writing secure code, and then you commit your auth keys to GitHub for the public. GitHub does go through this and try and suppress these kind of searches as they find them, but it's not actually removing the data. It's just making it harder to search for them. Hell, even the hackers are bad at it. Half the malware out there that does full disk encryption and then forces you to pay a ransom don't even implement security properly. So they can get bypassed and unencrypted easily because they use bad timing seeds, or they don't use their nonce properly, they use the defaults. It's hard. Security, well done in all levels, is hard. And to talk about how terrible things can get, I'm going to take a slight sidestep and talk about a research study I did a couple of years ago. From mid-2012 until 2015. There was a small hosting company that I used to work with, and they got hold of me and said, we're having a massive problem with people hacking our websites. We run a shared hosting, people install their own little websites on it, they get them up and running, and not a week goes by when we're not helping 5 or 6 of them reinstall everything because it's been wiped or vandalized. And they needed a way to be able to figure out how bad this actually is. How much is it costing them to do this? And can we improve the situation? So I sat down with them, and we worked out the most commonly installed pieces of application on the hosting environment. We came up with a list of about 43 applications or libraries or frameworks. And I built a giant fingerprinting database. We ended up with 4,800 different versions of the software. In total, we had to create fingerprinting for 10 million files. And then we started running it over the entire hosting environment. What versions of what software are running? And we kept doing this, and we did this every month. We're doing something like 6,000 websites scanned a month. Came up to about 255,000 scans, just so we could see what happened over time. Did things change? Did they stay the same? So once we had that, we then built a huge cross-section of what the vulnerabilities for those versions are. And so we could start saying, well, are these vulnerable? We know what they're running. We know what version they're running. Is it vulnerable? This particular talk, I have the results for July 2015, mainly because after that they started shifting stuff around. There was less stuff being run on the shared hosting. It all went off into little separate containers. It was much better, much more secure, but this had the best overall result. Talk about picking your results. If there are no data scientists here, so I can do that. It remained fairly consistent. Now, just to say it, before we get into the very heavy stuff, what do you think the most popular piece of software was on the hosting environment?
WordPress?
Nope, not WordPress.
Operating system?
Hmm?
The operating system itself?
Oh, well, there was only one operating system. Lots of applications on top. Anyone else want to try? PHP MyAdmin? No? That's what the distribution looked like. Maybe that will help. MySQL, software stack. This is more the actual web applications on top. All right, I'm going to remove a couple of them just to make it even more interesting. Not Zendesk. I don't think there's Zendesk. Zencart. No, Zencart's actually down here. Was that a remote shell? Wasn't remote shell, but yes, it could very well have been a remote shell if they'd left them all on. So Joomla uses TinyMCE. So does PrestaShop, and I think Virtuemart, I think OpenCard, PHP a bunch of different applications actually use TinyMCE, which is quite important because it means if there is a vulnerability for TinyMCE, it could potentially make those other things vulnerable too. Don't to think about. It's not always the case, because sometimes only bits of the...
What is TinyMCE?
TinyMCE is what you see is what you get editor that you drop in, and it provides you with a little bold, underline, italics text block area. Yeah, kind of like FCK editor. Now back to the heavy stuff. How bad do you think it was? We scanned 6,440 websites that month. On it, we found 1,082 websites that had something we knew about 2,300 pieces of software we could identify. So it was about a 1 in 6 websites. The other ones either had something custom, or they were just a placeholder website, or they had a piece of software that was very uncommon. So how bad? 2/3. You're way more pessimistic than me. That's what it looked like. This is using the CVE's scale for vulnerabilities, which is a scale from 0 to 10, which takes into account how severe it is, what they can do with it, how easy it is to exploit, is it reproducible, and then puts that on a scale of 0 to 10. 0 being, or 1 being very minor here, or absolutely no problem, up to they have root on your box and now own you completely, and your bank account, and have repossessed your dog. So it's not too bad, actually. We've got quite a few here that are on the not vulnerable side, almost 800-ish. However, on this side, we have something like 1,000 that are everything is awful and on fire, and then a little bit in the middle.
That's a weird distribution.
It is a weird distribution. So we took the most threatening vulnerability of the list. So if something was vulnerable to 10 things, and one was 10 and the others were 4 or 3 or 4 or 5, we took 10 and pushed it very far to that side. Also because on websites, if you really mess up, it tends to be an all or nothing affair in a lot of cases. Let's maybe classify this a bit with the actual CMS systems, just to get an idea of who might be to blame for this one. I have no idea what Drupal's doing in the middle there. Shame on you, Drupal. Shame. It is worth noting that WordPress has an auto-update system. So the people kind of sitting here with WordPress don't have much of an excuse for that. Joomla, on the other hand, doesn't have an auto-update system. That's not me calling out Joomla on this matter. This is just the results we got. People who were using Joomla did not update. It is kind of depressing. But why? Why is it so bad? I mean, sure, we got a lot of software out there, but we got some that aren't and some that are. But why is it so bad? And it came down to one very simple equation. It comes down to time. You see, the amount of time it takes from a piece of software to be released, a particular version, to a vulnerability being found, not being created, because the vulnerability was there from the beginning, but for it to be found and publicly disclosed, had a median time of about 20 months. Although you can see this is a very long tail with a very steep curve. So in most cases, within three months, 25% of all software versions have been released have a vulnerability discovered. So either, if you want to be okay-ish safe, you want to make sure your software on average is younger than 20 months, the version you're running. If you want to be extra, extra safe, it should be 3 months. And that's fine, as long as the average version of the software, the age of it, on the servers, had a higher median. A lower median, as long as it had been there for less than 20 months. Any guesses? So we're sitting here at about a median of 27 months. I think it was 27 months, yeah. We have a lot here right in the very new column. That's great. That means some of the things we did, which was once we knew what versions they were and if they were vulnerable, we'd send notifications to the owners and say, hey, your website, it's vulnerable to these things. You should update it. And that was great because it meant people started updating. But there's still this long tail of people who don't care, or the updating process is too difficult for them, or it breaks something in the system. So if they update Joomla and the templates were hard-coded and there's no way to update it cleanly, no one did it. What was quite interesting with these little spikes here. It took a little while to figure that out. I had to look back through some documents and some of their marketing. It turns out they did a special here, here, and here, really cheap web domain website. We'll set up for you, no questions asked, extra special, very cheap. And people came along and said, great, we'll have a website. We wouldn't have had one before, but it's so cheap. Get a website up. And then they don't care about it, because why? It was cheap. Take it down if we don't want it anymore. This is actually good in comparison to what it was. So if we look back 2 years before this, before we started telling people to update, it looked like that. That is horrifying. Actually, let's stack those on top of each other for a bit more clarity. You see, actually telling people to update actually got people to update. We had here 500 websites that had been updated within the last 1 to 2 months. Here, this is only 300, and that's in the last 6 months. And then this long tail that stretches all the way out here. Of course, doing this meant I came across some of the worst things I'd ever seen in security and in web development in general. And not all of it was just based on the websites that were being run, but the software I was looking at. And it was scarring. So for instance, this was a version of a piece of software. And trying to figure out if another version number came before or after that was quite difficult. Because you say, well, if I'm on this version and there was a vulnerability for another version, was that version before or after this one? That is actually not the worst version I've ever seen. The worst case of version I ever found was in a little thing called TimThumb, which is a little drop-in for Joomla. It was a one file, and the version was stored inside the file, and the developer working on it would occasionally forget to update that version number. OpenX, we came across this when I was testing this. OpenX ad server, which was previously PHP new ads and has now become Revive ad server. For a period of almost a year, from November 2012 to August 2013, there was a backdoor in it, a deliberately installed backdoor that someone had put in that no one knew about, which meant we had a bunch of people who were using literally a piece of software that was calling home and telling everyone, whoever owned this, hey, I'm compromised, use me. So shortly after that story came out, they did change their name to Revive Ad Server. So if you are running that's on your services, you might want to go and check up on it. And then this was the worst offender on the whole security side. Please note, Joomla is now on version 4, 5? 3.81. Okay, my numbers got too big. This was back in 2015. At that time, 2-point-something was out. This person obviously had heard of the concept of updating. I mean, they've installed multiple versions of Joomla, but they didn't get rid of the old ones. They just moved it into a backup folder, or a backup folder, or backups too, or temp, very original. These folders will get scanned for. There's a lot of tools out there that will scan websites and look for folders like backup and temp, just to find situations like this. Also worth noting, you'll notice here we've got administrator and, well, backup administrator and backup. Joomla 1.5 had so much copy-paste in it between the main folder and the administrator folder that my software started picking up the administrator folder as a separate install of Joomla. That is not the case with the newer versions, thankfully, but it was also quite an interesting find because it did inflate some of our numbers and make us very, very worried. So what do we learn from this? Versioning. Pretty much whichever software had bad versioning had bad security. And I mean, non-existent security, did not actually issue patches for security vulnerability notifications, didn't have anywhere to tell them about security vulnerabilities. So I'm not talking about Joomla or WordPress or one of those ones. We're talking about there's a lot of smaller applications that there is no proper maintenance of. If you have an automated way to patch or update your software, people would use it, which was great. And if that upgrade meant that the plugins or templates would break, they would not do it at all. We had situations where an update to WordPress broke something, and the person contacted us and said, please revert it back to the old version. And we said, it's vulnerable. They said, yeah, but it worked. And finally, probably the most interesting issue we found was that patch fatigue exists. And you saw that very small time loop between a version coming out and it being vulnerable. We had ones that were within 1, 2, 3 months' time. As soon as we got a new vulnerability, we'll send it out to the customer and say, you were running this version. It's now vulnerable. Please update. And the first time they got that, they're like, great, thank you, great service. We'll update it. We're no longer vulnerable. And then 2 months later, we'll send them another notice. Hey, you're vulnerable again. Oh, OK, thank you for telling us. Update it. And then 2 months later from that, we say, hey, new vulnerability, update. And they're like, fuck off. Take a hike. So maybe we're through denial now. We're on to the next stage. Anger. Someone is to blame. Why doesn't someone do something about this? The universal shout of the disenfranchised and angry people. Why doesn't someone not do something about this? Well, private industry keeps threatening security researchers. This is still a thing. It's improved, and some companies have started doing bug bounty programs to help proper disclosures of vulnerabilities to the companies so they can patch them and deal with them. But it is still a very contentious issue, especially in some industries like the finance industry. I myself have been threatened because I pointed out to a financial institute that their support software was not doing any kind of sanitization in the outputs, and I got sent a legal letter by their lawyers. Nothing says confidence in the systems you use that handles your customers' payment data like using a company who doesn't care about security. And I'm not going to mention that it was a British company. Then there's these guys. I think there's actually some people, maybe even in this crowd, whose financial details have been disclosed. If you've ever lived in the US, most likely has been. They lost 143 million records of people's most sensitive financial information and addresses and social security numbers and other stuff. They're, I think, based on the outcome of this, going to come out making money off this at the moment. Heathrow. Heathrow just lost 2.5 gigs of private data about their security, including the route the Queen takes to the airport and the position of all the CCTV cameras around Heathrow. Oops. AOL. AOL's lost 120 million contacts over the last few years. Once again, this is not to shame these, okay. Shame. But it's not to shame these companies. Because these are large companies. They have large systems. Some of them deal with a lot of legacy. Some of them are in places they're not even aware of. Vulnerabilities happen. Stuff gets compromised. The best thing you can do is try and mitigate it as much as possible. But they still did lose 120 million records. Adobe. I don't like them, but I'm not going to shame them on this. They lost 152 million. They were actually one of the biggest disclosures in a long time. For about 3 years, they were the big one. Everyone went, well, remember when Adobe lost 152 million records? Oh. And then, well, yeah, well done, Yahoo. Well done. Yahoo really likes losing data. They lost 3.5 billion records through multiple different disclosures over time, so the same ones over and over again. Interestingly, this is the only one I know of that actually had a financial impact on the company, because Verizon, who was buying them, knocked off 350 million off their sale price, which doesn't really help any of us who might have been disclosed in this, but I suppose it might make people aware of it in the future. Miko Hyphen, Chief Research Officer of F-Secure. He said this 2 years ago. Still true. You ask him today, he'll say, yeah. Now twice. Okay, all right, so it's bad. Maybe we need some kind of standard. Some standard to align our security with. Some standard we can all get behind and really button down and get sorted. Yeah, we do. We actually have a bunch of them. The ISOs, the RFCs, the PCDSS, if you ever have to work with credit cards, you need to do that one. NIST, that's National Security for the US. If you want to work with them for the government as a private company, you need to abide by that. So we got a bunch of them already, and some of them are conflicting. They eventually, NIST came out recently and said, you know what, that whole password resetting thing every couple of months, that's a bad idea. Maybe we should stop that. PCI is like, do it. So now you've got a choice. You either deal with credit cards or you deal with the US government. Which is worse? And honestly, you think, okay, fine, maybe I can research all of them, find some common ground. Sure, you want to research them. That top one. You want to read it. That's 650 euros. Or 650 pounds now-ish, roughly. Yeah. If you want to be certified in that, that's 50,000 euros. That's just one standard. So you can't read it, but you have to abide by it if you deal with certain things. And you can't be certified in it unless you're willing to fork over a large amount of money. Which brings us to the next step. Well, if private company doesn't do it and we can't come up with standards with open bodies, maybe we can regulate it. Maybe we can get the government involved in really helping us come to the bottom of how to solve this problem. They're really causing more problems than they're solving, aren't they? There is a ray of hope. Things are slowly starting to progress. We're starting to see more regulations coming out that actually require organizations to disclose if they've lost data. Some of it's voluntary still. Some of it is becoming more regulated. We've got things like the GDPR, which is coming out, which is going to be a pain in the ass for a lot of you. Anyone here involved with GDPR? Yay. However, that does have a whole section on it about disclosing that you've been compromised, letting people know that their data is out there. That's good. I mean, not having to regulate it in the first place sucks, but having it regulated also means it will happen in this case. In fact, we've even seen common sense coming out of regulations. Julian King, just last month, said, fine, let's stop this conversation about backdoors. It's not going to work. We'll find alternative ways to handle this kind of operational security. And not to be outdone, the US followed in their tracks shortly afterwards, but somehow completely missed the concept of end-to-end encryption. All right. So we've dealt with denial. We've dealt with anger. Now we come to the bargaining. Yes, maybe we should install something custom. Maybe we can do something that will secure us, and we can just drop it in place, and we'll spend lots of money, and it will fix the problem. Except for the fact that, just like antivirus, we're introducing these kind of problems into our system. And the story goes here, the NSA and the Russians both had backdoors in the system, and the NSA got fed up of sharing the systems, and they ratted them out to Juniper, ratted out the Russians to Juniper. And while auditing it, Juniper discovered the NSA's backdoor. That's the myth at the moment. Bugger. There is a reason why security people drink. And it is all of this we just discussed now. Okay. Everything's awful. Nothing's going to work. We're screwed. Why, though? It's because our security is not effective. We don't treat security in the way it should be. Most of them, our security practices are ineffective because we do security in isolation. Security is not something you do in isolation. It is a holistic thing. And I'll show you why. That's your area of influence. Your software, and maybe your dependencies. You have control of that. Dependencies to some degree, depending on where you work. But there's all this other stuff that you have no control of as a developer. You need to get out there and actually take actions in those areas. And the reason why is, well, let's scale these based on the lines of code that actually are involved in these. So what you write is just a very thin layer in the world of security. There's all this other stuff you need to deal with. In fact, we're leaving out a very important component in this already. So let's say the human DNA is about 7 billion lines of code. That's the biggest area you need to be concerned about. That's where the most bugs exist. And there's ways to deal with those. You don't have to tackle them yourselves, but you need to at least be communicating with the parts of the company that do those things. HR and training, great. We do things like spear phishing our employees. That works. It might make them a little paranoid, but that's cool. We like a little paranoid. Get your system administrators. They are your friends. Bribe them a lot with whiskey because they've dealt with more security than you, and they are already heavy drinkers. Your security needs to be led. It's something called security in depth, where if someone can compromise one part of your system, they can't just get everything. There needs to be additional barriers in the way to prevent them getting to the next area. Maybe the first layer is get onto the secretary's computer. But then you talk a lot in security about lateral movement. That's where they compromise the system somewhere, but they can't go further with what they have, so they have to find someone else to compromise before they can go further up. You compromise the secretary, then you need to get onto a developer's machine, and now you can get server access. You need small surface areas. The smaller your surface area that you expose to the world that is available outside your system, or even inside your company, the less chance of you being compromised. Alertness. You need to be aware when something strange happens to your system. We have situations where companies don't know they're being compromised for months, but you're more likely to be woken up in the middle of the night by one of your alerting systems telling you that your disk operations have skyrocketed and there's a ton of traffic inbound or outbound way above normal, and you go, oh shit, someone's trying to exfiltrate lots of data from our system. No one's going to phone you and go, the hackers are in our system. They're going to be like, there's something wrong going with the system, and there's graphs with red. And then you need to be ready. You need mitigation in place. You need a way to shut down parts of your system. Or you need to make sure that the bits of your system that are exposed can't compromise other parts of your system. If all your code that deals with your credit card system is completely separate from other parts of your system, if the other parts get compromised, they can't touch the credit card data. The more you separate it, that's also when they talk about things like your MySQL user. That's one of the most basic levels. Your MySQL user for your website should not have the ability to alter tables or create tables or export data. Just insert, update, and read. That's some of the basic things. But then you can also split it into different databases and have different servers only accessing different databases. And then finally, security is about trust. Trust? Haven't we just talked about how everything is absolutely awful and we shouldn't trust anyone? The thing is, we do. In security, we do trust people. What we need to do is be aware of what we're trusting, because that's where we can misplace our trust. if we're not aware of what we trust, that's how we get compromised. So, trust is a chain. It's a simple one. We're having a conversation. These are the layers of trust. I trust that my computer is not compromised. I have up-to-date patches. I suppose antivirus there if we want. I trust that the software I'm using doesn't have vulnerabilities. Have we had security patches for them? Has there been security research into them? I trust that all my software is configured properly. Because that's also another problem. The number of MongoDBs that have been found online with no security passwords on them, open to the world. I trust that the network is properly configured and secured. And that's where you need your good system administrators. I trust that you are who you say you are. If we're having a conversation, I need to know who you are. Are you the person I meant to talk to? We can do that with TLS certificate peer verification. So if anyone ever tells you to turn that off, or authentication. I'm talking to your website. I know who you are because your certificate confirms it. And when I talk to you, you know who I am because I put my username and password into your system, and you can verify who I am. I trust that we're allowed to talk about this conversation. And that's our authorization, not to be confused with authentication. Authentication, I am me. Authorization, I am allowed to do. I trust that what you send to me and I send to you has not been tampered with. Hashes, signatures, CRCs. I trust that what we talk about us is just between us. No one's eavesdropping. That's your private public key exchange systems. I trust that your computer is not compromised. I hope. I have no way of checking that. I trust that what we talk about, you don't share with someone else. There's no software there to fix that problem. We can maybe restrict it with contracts and legalese and terms of service. But that's about the best we can do. When you give your data to Facebook, do you trust them with what they do with it? You sure they're not going to hand it on to someone else? I mean, that's their business model, pretty much. I trust that the users of my system won't be the weak link. Where we can, we do try and change this chain into a mesh. Two-factor authentication is a way of creating a mesh out of a chain, which means that if one of the two links breaks, I lose my two-factor authentication or I lose my password, I'm not compromised. We can extend that as well into the other system. We can have double-check systems. If you're dealing with a lot of financial transfers, you have more than one person who has to approve something. That's making sure that two people have to be compromised before a transaction can go ahead. We do signatures on messages. We encode our HTML output when we print it out from the database because we don't know who put it in there in the first place. So we need to verify. We will encode it to ensure that even if something bad goes in, we're not going to print it out. Wherever you have an assumption, generally, is there a way to code that assumption? Now, there are common mistakes, but I am running short of time, so I'm going to go through these very quickly. Generally, the common mistakes we make as developers, generally, especially around security, has to do with compromising security or hashing. And that normally leads to reduction in things like time to crack passwords or ways to compromise our system because we left something out on that chain or we broke something. And generally, it's because we implement something badly or we follow bad advice. Authentication being one of the big ones. Authentication is quite often a problem. There you go, two-factor authentication. Use that, job done. You can now use Google two-factor authentication for your website. I can't actually give you a better recommendation than just doing that. Or actually, even better, why do you have people's user accounts on your system? Put it on someone else's system. Let them deal with the security implications. Quite honestly, now, especially with GDPR, less data is better. Data is now toxic. It used to be valuable, now it's toxic. It comes with a fine, a price attached to it. If you don't get it right, you're in trouble. Sessions. You don't do sessions right, your authentication is completely bypassed. Very important. Do not roll your own authentication or session systems. Because you can end up with situations like this. This was a vulnerability in PHP-MyAdmin. And to understand what the vulnerability is, you need to understand the language quite deeply. This was to allow the admin user to unset someone else's session. What it did, though, was before it closed the current session and opens up the other session to clear out the other session, is it runs parsestring. Parsestring is a really horrible function that takes everything inside of that scope and puts it into the global variable namespace, which pretty much means, so that writes session to disk, and that extracts everything in the URLs, which means you can put something in the URL $_session equals whatever you want. And you can override the existing session to include I am admin. which pretty much means gives you access, admin access on my PHP MyAdmin without even having an account there. Encryption.
Is that fixed now?
Oh, it's fixed. It's definitely fixed. That's been fixed for a while now. Never roll your own encryption. Why? Pretty much, I don't have a PhD in maths. And I have spoken to people with PhD in maths, and they're like, encryption, you get that wrong. You're screwed. I don't want to do it either. Avoid old tutorials on encryption. They change very quickly. The recommendations fall out of favor. You want to keep up to date. That is actually a very good URL maintained by InfoSec security researcher with the latest advice. These slides will all be up online, so you can have a look at them then. Also, avoid bad old advice like this. Hey, I get this error message. Don't worry, all you need to do is turn off peer verification, and it all works fine. No, bad, terrible. Do not do that. Figure out what the correct solution is. Thankfully, from PHP 5.6, that is now all handled automatically. You don't have to care about it. We have Daniel Lowry, very nice guy to thank for that. He has probably saved more people's ass with security than everyone else in this room combined. Hashing, never roll your. You might be getting a theme now. It's a one-way encoding. It's good for integrity checks and good for comparisons. You don't use weak hashing functions because we now have giant rainbow tables where before it's like 690 gigs on my computer to be able to run a hashing table. No one has that kind of space. Now everyone has that kind of space. So don't do that. This has just recently been updated. Have I Been Pawned is a great website to see if your email address has been exposed in one of the many data breaches that have been made public. Last time I updated that, actually the first time I updated that, the value was at 278 million. That was in February 2016. February 2017, I updated again, 1.4 billion. That's less than a year. Also, watch out for bad implementations like this. Who can tell me the difference between these two functions? Crypt and password verify. They both return the same result. They both will give you exactly the same result. It's a hash crypt, so it's a one-way crypt. It's not an encryption. It's a hashing. The difference between these two is this one, password verify, is timing attack safe. And this is the hard thing about security. You don't even know what you're getting wrong. I didn't know about this until I started researching the topic. And what that pretty much means is you take two strings and you compare them together. The amount of time it takes to compare them over a long period of time, if you do it repeatedly, there is a small time difference. Because once you reach two characters that don't match, you quit. When you're doing that with a hash, you pass a password in, it hashes it, it compares the result. If they don't match in the first character, it exits. If you get almost all the way down the string and exit, there's a small time difference. If you iterate over that repeatedly, you can figure out how far along that hash it's got. Who the fuck would think about that? I mean, that is seriously mind-boggling. But there is a small time difference, and it has been used in the wild to compromise systems. Yeah, can be used. In fact, you can use it in your code. If I go, this is my username, and you do a check. Is that username exist or not? OK, not, go away. If it is, OK, now do the password check. There's a time difference between those two functions. So what you should do is do a check of username and password, and if both of them, or maybe add some random timing in there, just a couple of milliseconds, just to mess with it.
Which way around is the password verify encrypt? Which way was the good way?
Oh, password verify is the good way. That is timing safe. Crypt is just a crypt function. It doesn't care about the, it's this. Yeah. That is most optimistic, is the most optimized way of doing a string comparison. I'm going to skip this one. This is an interesting one. If anyone wants an interesting talk afterwards, I can give this. In fact, password recommendations change. So adding a password needs rehash function in there to your code also helps because it means if a new recommendation comes out, your code will automatically update when the person puts their password in. Because you shouldn't have their password in the first place. But when they give it to you, you can rehash their passwords. Randomness. Never roll your own. Non-determinate randomness is critical to encryption. It's also very hard. That dual elliptic curve DRBG was in use for 7 years before someone pointed out that maybe it was not as strong as it was intended, and the fact maybe that the NSA had paid the RSA, which is the company RSA, a couple million to make it the default option for encryption on their services for a very long time. Oops. Know where your randomness comes from. That is not cryptographically secure random. These are. And if you really want to make yourself dependent on OpenSSL, I suppose. Yeah. Information disclosure. This information on your machine, when you hit someone's website with a header request, you get this information back. What does this tell you? It tells you they're running Apache and they're running that version of PHP. Not a good idea, because then people go, oh, that version of PHP, well, I know what that's vulnerable to. Don't do it. Also, turn off your errors, because this discloses information about your server, and it doesn't actually mean you're compromised, but it gives them vivid information to leverage. And then finally, social engineering. Weak password reset processes, not good. You need proper customer support training. This is a very, very, very interesting story. I also don't have time for that, but pretty much it means two companies did exactly as their process dictated, but what ended up happening was that chap's Twitter handle was compromised because his email domain was stolen from GoDaddy, because GoDaddy gave it out because they were given the last 4 digits of the credit card number, which the hacker got from PayPal, and PayPal got it from them by getting the social security last 4 digits from GoDaddy. Very funny story. All right, so we've gone through the five stages of grief. Now we're on to a new stage, because there is a little bit of hope out there. We know that our security needs to be holistic now, at least. We're aware of it's more than just what we do every day. So a couple of guidelines. ABC. Always be patching. If you have a dependency right now that prevents you from updating your software, fix it now. Fixing it when there is a major problem is not a solution. We have this even at booking. We had to spend a lot of effort to undo some messes, but it was well worth the effort. Version properly, please. Major version, minor version, patch. If it's a backwards compatibility break, update the major version. If it's just a new feature, update the minor. And if it's just a security fix or just a minor bug fix, patch version. Very simple. A lot of people don't get that right. I doubt anyone in the crowd here is going to get it wrong, but worthwhile going over anyway. Don't become comfortable. If you know there's something in your system that is vulnerable, make sure it's very visible on everyone's radar, because after a while, you'll forget it's there, other people forget it's there, and then suddenly something horrible goes wrong. Oh, read. Half of IT security is reading, knowing what's happening, what's happened recently. It's a lot nicer now. We've got nice flashy websites and logos, and when a big vulnerability comes out, it looks very cool. It's still worth keeping your eye on what's happening, especially with the software you use. Sign up for the CVE reports from Mitra. Know when there's a vulnerability out for your software. Have a better process for dealing with locked accounts and resets. You shouldn't be able to phone your customer support and bypass them at your company just with a bit of social engineering. Have a compromise strategy, because something's going to go wrong, but you're going to need to be able to very quickly shut down parts of your system when they are compromised. You don't want to shut down your whole business because someone's compromised a part of it, but you need to be able to isolate that part very quickly. Only store what you need, especially now with GDPR. The information you store is toxic. If it leaks, if someone steals it, you have to explain to people why. OAuth is a great way to make sure someone else is responsible for that. Mistakes will be made. We're all going to make mistakes. We're all going to break things. I've been there. I've been hacked. Just so if anyone feels bad about it, I've been hacked a couple of times before myself. Build rate limits now. If you have a system that costs you money to run, every single time a call gets made, make sure you've rate limited it, because you don't want it to be DOSed by someone and have no rate limits on it. Monitor everything, because you will be alerted by a spike in your graph before your IDS system. Decouple your roles. Separate out your databases between different servers. Make sure that the system only has what it needs to do, what it needs to run. This is a group performance. We cannot do security individually. We have to do it holistically. And this is just a little bit of hope to go with all the bad I've shared. Thank you very much. If anyone wants to give me some feedback, I love to have feedback. Nice feedback saying, hey, very nice, flashy hair, look great on stage. That's very nice. But if you have something that says, I really like what he did this, or he could do more of that, that's the kind of feedback I really would like. All right. Any questions? Do we have time?
We don't have any time for questions, but I take it afterwards you can come up and...
Yeah, please come find me during the break if you have questions. I'm very happy to answer them. Or you can send me a DM on that, and I'll try and answer it as best as I can. Cool. Thanks very much.